Vignesh. I'm from ThoughtWorks. Probably if you're around from yesterday, Amit and Yana also presented a bit about how they are working on qualifying libcode. So today I'm going to talk a bit about a process of compliance in automotive. Like what are all these standards that are present in automotive? What are all these standards software developers need to adhere to automotive, while developing automotive software, as well as how you can make that process a continuous one. Added to that, if you are developing using Rust, what are all the inherent benefits that you get through that process? About ThoughtWorks, ThoughtWorks is a global technology consultancy company, and I'm from a software-defined vehicles team within ThoughtWorks. We are a small team. We started a couple of years back, experimenting on new topics to crack the complexity of software-defined vehicles so far. Getting into the topic for today, just before that, we can see the outline of what I'm going to talk about. Since we also have non-automotive folks here, let's just spend a couple of minutes on understanding what the standards are and what this compliance means in automotive, and also talk about specific standards that are relevant for applications of software developed for automotive, how compliance is happening today, the pain points, and then see about the concept of continuous compliance and how Rust makes the process more easy. So let's understand a bit about need for standards in automotive. Cars of past, this is one of my childhood favorite cars. Cars of past are very electrical and mechanical systems. Not so recent past. So they don't have a lot of electronics in it. They don't have lot of software in it, which makes the failure of parts predictable. So if you have a mechanical car, you can predict after how much wear and tear the part will fail. But current days, modern cars, not such fancy one, even the simpler cars have a lot of software features, a lot of electronic features, things like adaptive headlights, airbag, cameras for reverse assist, a lot of things. So the predictability of failure of each of these components is not very straightforward. So that's pretty much why we need standards to be enforced so that the quality of software can be a given thing when you use your car. So again, in recent days, we have been seeing a lot of software is getting into the car. And this is a famous article from IEEE tagged software is eating the car, and it is indeed eating the car. And you're a lot more seeing software power is taking over the horsepower in terms of user appearance or attraction on cars. So users doesn't, these days, just look at how the car cycle parts and how much horsepower your car gives, but more of what are all the features, functionalities, and user experience your car provides. And that depends a lot on software. And it is predicted that 10,000x more code is going to be written on cars of coming days. It means, again, compliance is a very big issue. How can we make all those software compliant and the process itself is seamless into the development is a big talking point these days. And you have seen a lot of folks talking about compliance yesterday and even today. One approach, let's delve deep into what are all the compliance standards in automotive which are relevant. I have one on the screen here, but there are bunch of standards and compliance are present in automotive so far. So things like ISO 26262 for functional safety, and you have for cyber security, you have for autonomous driving, and there are a lot of different, I don't want to bore you with ISO numbers, but yeah, there are a bunch of standards that automotive software needs to adhere to. But particularly for software development projects or software houses of automotive OEs or manufacturers, ASPICE is an important process. ASPICE is automotive SPICE. Again, it's an SDLC of how you develop your software for car. It follows series of stages, series of steps, ranging from how your car features can be broken down into different requirements, how those can be implemented as software components, how those can be unit tested, integrated into in the overall scheme of things, and then tested as a car at large. So today, this ASPICE, which is most relevant to software projects, today we are going to see how we can approach the compliance for ASPICE in a more iterative way. So just a bit on how compliance process is done today. So what is the stages we have to go through in order to do the compliance assessment? The first step is, once you're done with your application, once you're done writing all your code, there is a series of documentation produced. These documentation can range from definition of your requirements, definition of your test cases, results of your test cases, so on and so forth. All these documentation needs to be packaged and need to be audited. So far, in most of the cases, this process is completely manual and being taken care by someone who doesn't write the code themselves. It means there is some other team or person who are sitting on the other side than just writing the code, collects the information about the code, documents about the code, and then just goes about building this audit document, which is not right, which is disconnect from your development workflow, and your developer cannot get the feedback of non-compliance while developing your software. In the sense, if you are doing something wrong in terms of not complying to the standards while you're writing code, you don't have that feedback immediately, which means it takes a lot of cost, time, effort when non-compliance is identified at the end of your software delivery cycle. So continuous compliance is a practice and also a combination of tools and techniques to automate this whole compliance process in automotive. Let's see what are all the important things continuous compliance talks about. Few foundational principles that we wanted to associate continuous compliance with are code as documentation, like all the information that you have about requirements, test report, test cases, whatever it is, have everything as close to code as possible. Make the auditing assessment itself an agile process, in the sense, whenever you commit a code, you can ideally do a audit process happening in your pipeline, which gives you immediate feedback whether your code is audit ready or not. Yeah, so that's what the ASPICE assessment for particular software engineering groups, which makes it easier to have a audit ready package of your software at all the times. So what are all the things we need to have in order to achieve this? First one is, again, bidirectional traceability and consistency, which means the requirements that you are defining for your software feature needs to be linked to every different part of your development parts, like every different blocks of your development parts. It means that if you're writing a requirement in your Jira, let's say, it needs to be linked to the software component that you're building in Rust. That needs to be achieved. A pipeline for continuous assessment, and also a script to identify non-compliance if there is any. And also a bunch of other analysis that we can do in terms of architectural analysis, in terms of linting, clean code analysis, so on and so forth. And at last, we can generate a web and PDF documentation which can be used for auditing themselves. So that's at large about continuous compliance. So every automotive software house will have their own process methods and tools. But I'm just showing an example of how this can be done using open source plugins and tools available now. So this can be adopted to any of the input sources, which means that Jira can be replaced with your own sources. But if you have the flexibility, you can do that. This is one sort of a reference implementation of how you can use open source tools and open source plugins and still achieve continuous compliance at large. Let's check the code that I have now. So I'm going to show you, let me zoom in a bit. Is it visible? Yeah. So the project I have at hand is in a POC that I did for collecting data from a car. So it's a telemetry project, so where you can your application collects a lot of data and then streams that data to AWS. That's just a bit of context, but you can see in the project hierarchy, you have a bunch of Rust code which you will be familiar with, the cargo file, the source folder, so on and so forth. But importantly for this showcase, we are going to see about the documentation and how the requirements, test cases, and everything is linked. So at the heart of everything, I'm using Sphinx here. Sphinx is a documentation tool from Python, Python world. Yeah, so it does a lot of these traceability and other things inherently well. So we see the Sphinx configuration file here, and you can see a lot of these unit tests and other dependencies, like dependent steps, are taken care just by writing Python code. For example, here we are seeing cargo test is being run, and then that output is getting stored in a value. Yeah, and these are all the plugins that are used for achieving every bit of this. I'll show a lot of traceability and how these traceabilities are automatically done, but these are all the snapshot of plugin that are used in this reference implementation. Few examples that I wanted to show. We spoke a bit about the larger requirements and architecture. You can still do the architecture in an open source way using PlantUML, and PlantUML does give a document-friendly or output-friendly image at the end. So by doing this, we can have all those information as close to code as possible. And then just to touch upon what are all those, how those software requirements are written, Sphinx use the restructured text format, which is similar to Markdown. You can see an example of how a traceability matrix is generated in this code block, as well as a bunch of other documents being linked here. One more example of how a requirement looks like here. You can see there is a requirement ID, and there is a brief description about the requirement and a detailed description. So this will all get automatically generated as HTML and PDF files, which can be used for audit at the end. Let us quickly check how the output looks like. I'll go back to the browser. So this is how the output looks like. All those content that you have written is beautifully built into a read the docs format. So you can see few assessments are being done here. One of them is if few are qualitative assessments and few are quantitative assessments. You can go about in your own way how you wanted to assess your application based on the criticality of the software that you are working on. Yeah, you can see that unit tests are failing here, which needs to be fixed, and bunch of things around the technical requirements, so on and so forth. So you can see on this place, the traceability matrix is generated. It's just a very simple implementation to showcase how these things work. So I have just created few software requirements and then detailed unit software implementation and test cases. You can see each of these are different part in the restructured text document, but while building and producing the output, everything else is linked. And one cool feature is that Rust can be automatically read by Sphinx now. It means that Sphinx so far didn't have the ability to read Rust out of the box, like there was no plugin to read Rust, but we do have something now to read Rust code directly by Sphinx. So few other examples I wanted to show today is you can also inline your code. You can also see how the code, for example here, if you can annotate on your code with docutext, those are picked up by the tool by itself, and then which is attached to the output, as you can see here. And one more thing is we saw the architectural design, and that's attached to the output as well. The same thing can be packaged in the form of PDF. it can be audited. So this can be used as a dashboard of your compliance audit, and you can go about do your compliance assessment from there on. Jumping back into the slides. Again, I just wanted to touch upon continuous compliance, how it is applied in real world. I think Ferrocene, this compiler, the Ferrocene compiler is actually qualified through such similar documentations. It's not exactly one-to-one, but it's an example of how you can use open source tools and techniques, still generate a lot of these compliance relevant artifacts, and go about complying your, or go about standardizing or qualifying your application. So this is one real life example that we can see even today. Yeah. And then so far it's all about continuous compliance. Let's see how Rust makes continuous compliance very easy. This process at large can be applied to different stacks, but particularly for Rust, since we have a very cohesive and robust tool chain, everything else is very seamless. So we can just run cargo build, cargo test, cargo format. Everything's one by one in your CI pipeline, and everything falls in place. But on the other hand, if you are using, let's say, C or C++, you are relying on different tools from different parties. Those needs to be downloaded, installed, and then operated in a multiple different way in your CI pipeline particularly. And one more thing which is very underrated is all of these tools are developer friendly. That means you can do all these tools on CLI. I mean, just on terminal you can use these. Particularly in automotive, certain parts of these tools are not user friendly that way or CI friendly that way. So you have to figure out your own methods of how you wanted to extract those data and put it into your compliance document. That's always a issue in the industry so far. So having Rust-C, Cargo, Clippy, and everything combined and packaged through Cargo, it makes it a very easy and breezy process. Quickly, I wanted to show the CI code. I'm using Circle CI here. And you can see that just by using one command, I have installed all of those tools, and then running all the simple cargo test and then cargo clippy commands on the config.py. I'm able to simply get all the information out of the project. Yeah. So again, on the pipeline, if you can see, the output is stored as a document artifact. The same thing can be, it's not put in properly here, but you can see the same thing is built on a pipeline, and it is iterative that way. Yeah. So for every commit, you can realize compliance and make your project audit ready always. So benefits of continuous compliance, I think it's very inherent. I don't have to probably address that more. We achieve traceability. There is more accountability in the team in terms of being compliant to the standards from the source of where non-compliance could happen. In terms of the project themselves can be accountable and in control of compliance. Documentations which are accessible. Using such open source tools, you also get flexibility in terms of what are all the inputs that you can feed in. Like you can use Jira, you can use other tools that you're using in your project, and always be in the state of audit readiness. That's at large I have for today. Thank you so much.
Thank you, Vignesh. Does anyone have any questions about continuous compliance processes for Vignesh? Anybody? Oh, I'm going to start over here.
Yeah.
3. 1, 2, 3.
Thank you for the presentation. I was wondering, are you addressing only QM qualification with this, or also ASIL or safety certification?
It actually doesn't matter in terms of the processes here. You can identify your application, whether it is QM, ASIL, ABC, or D, but just the content of the documentation varies, the approach does not change. So if you are doing a QM application, you don't have to put in a lot of rigor in terms of building these documentation. The quality of these documentations can be different. But whereas on the other end, while you're doing ASIL-D, it needs to be much more tighter and stricter. But the way you write the content in your restructured text and the way you produce your documentation will still be the same.
Yeah. Okay. So it's more about the tooling or the framework for generating the artifacts, but not about the content itself, of course.
Exactly.
Yeah.
Correct.
Okay. Thank you.
Thank you. Over here.
So yesterday we had a presentation about kind of checking that libcore was conforming with requirements, and I think there was a question that came up on how we're going to manage continuous compliance with a library that's continually changing. Do you have any idea on how, like, would that be a manual process, or is there some kind of automated ways that you're going to generate new requirements, or how are you thinking about managing that?
I think for that particular scope of project, the answer will be a bit different, because in the libcore case, we have the core already implemented. We have to write the requirement. It's just requirements engineering back now. But on the other end, just as an overall topic, still the Ferrocene repository is compliant, continuous compliance. Like all the tools are automated, and then you have the similar workflow happening there. While you write your requirements, when you check it in, it's already being implemented so far. So continuous compliance as a goal is already being implemented in Ferrous Systems, Ferrocene, and that's the same process libcore qualification will also follow.
Okay.
Does it answer your question? No?
Evolves and changes, how you address that.
When libcore evolves and changes. Yeah, so you have to do a bit of, it doesn't change a lot actually. That's what we have seen in the last 6 months or so. But if it is changes, we have to do a bit more of requirements again, bit more of test cases again. It's all seamlessly connected that way. So what are all just changing now, we can just incorporate that into the existing code, and it all functions as is.
And we have one more over here.
Yeah, thank you a lot for the presentation. I think any insight to make the requirements process more easy with tooling is really appreciated in automotive. I think we all know the struggle there. One thing I was looking at, you had a plugin that was called Sphinx Rust. I remember at some point looking for something that can take Rust code and combine module documentation in a way that you can get rid of writing some of the restructured text yourself. Is this doing that? Because I remember when I was looking, there were plugins 8 years old, not matching anything. So I was just wondering whether you know about anything where you can move. You said you want to have it close to the code, whether there's something that gets some of the restructured text writing away from you.
No, it's not. So far, it's no. But if we have some capability, my larger idea or ask is, if we have that capability in Rust docs by itself, we can put in a lot of comments and documentations and so on and so forth, which can be easily read by Rust docs. But for now, it's not there. Yeah.
Any other questions here? No? Okay. So my question, Vignesh, is also how far away are we from being able to use this kind of software, use these kinds of processes to make the qualification process more efficient?
Yeah, the example is Ferrocene.
So we're already using it.
Yeah, we are
amazing.
We are already using it.
Good thing marketing knows about that.
No, so particularly since Ferrocene is also meant to be open source, it fits into that picture at large. But the pain points is also using specific tools from different vendors in automotive, particularly. How can we minimize that portfolio of tools and also make make it cost effective as possible is another thought.
Perfect.
Yeah.
Thank you so much for your presentation.
Thank you so much.